Okay, this video is going to be on skewness of the data, which is the shape of the data. You'll be looking at the graphs and determining what a description for the center and the spread and all that by looking at the shape. All right. Skewness is a measure of the asymmetry of the probability distribution. What does this mean? Well, you have all kinds of words that you use to describe data. If you look at this one, it looks like a bell. If you look at this data here, it's a dot plot and it looks like a bell. We call this being symmetric or being having normal distribution. Now, I'm going to tell you, y'all, the only thing that I can tell you about all this is you're going to have to memorize these words. There's no cute thing I can say. Sometimes I can, sometimes I can't. You're just going to have to memorize what it looks like and what the word is that describes it. So the word here is symmetric, normal distribution. Your data is concentrated towards the middle of the data. And it's concentrated here in the middle, and it looks like a parabola in a way. All right, uniform distribution. If you look, these are not exactly even, but they're nearly even. There's very little variation in the graph. Then we call that uniform. It is evenly distributed in a rectangular pattern. Skewed to the right. This is data that it says the data is concentrated towards the lower range. This is where the majority of the data is. But you have some data over here that is higher than the rest of them, so it skews it to the right. You name it by the tail. Look at where the tail is. This is on the right-hand side. This data is skewed right. This is skewed left. It does the same thing that the other. The data is concentrated up here, but you have a few of them small down here. And so this data is skewed to the left. Again, the tail is on the left. Bimodal. This set of data has two modes. As you can see, this graph here has two peaks. We call that bimodal. This one also has two peaks. You could almost say it has four peaks, but the concentration is here and here, so we call that bimodal. All right. In a crash test, 11 cars were tested to determine what impact speed was required to obtain minimal bumper damage. Believe it or not, they do all this in the car industry and in any industry. Find the mode of the speeds given in miles per hour below, and there's the speeds that they used when they were doing this. So if we order this data from the least to the greatest, we get this. It's ordered from least to greatest. And since both 18 and 24 occur 3 times, the modes 18 and 24 miles per hour, and this data set is bimodal because it has two modes. Okay, if you look at this one, this is a graph on Old Faithful. Old Faithful, a geyser in Yellowstone National Park, is renowned for erupting fairly regularly. In more recent times, it has become less predictable. It was observed that the time interval between the eruptions was related to the duration of the most recent eruption. The distribution of its interval times for 2011 is shown below. And there we are. And what would we say this is? Is this skewed left or skewed right? It's skewed left. And we will just look at this one. We're just going to look at skewness part. You could say this one might be bimodal, but I would say that it's mostly skewed left. And this one is skewed right. Now we're going to look at I've got some questions up here that I want you to see, and we're going to name them. This one is skewed how? Left. This one is uniform or normal, not uniform, normal symmetric or normal distribution. This one is bimodal. This one is skewed left, and this one is uniform. So remember to, just to learn those words, and you're going to have to memorize them. There's no shortcut here. Thank you.